I start with the divergence test, right? If I have no idea, that's usually the first place I'm going to start. So I'm going to take the limit, n goes to infinity of e to the negative n. What's that limit equal to? 0, exactly. Because when you have a negative exponent and you do limits, you make the exponent positive, so it moves to the denominator, and then that limit is 0. So yes, we got 0. So remember, get 0. The divergence test doesn't tell you anything. Divergence test inconclusive. If I got something other than 0, I would be done, but I didn't. So we got to do something else. And right now for us, that something else is to do the integral test. Okay, turn it into a function. This is 1 over e to the x if you need to think about it like that. This is definitely continuous. The denominator is never 0, and it's also positive on your interval 1 to infinity. It's actually continuous and positive everywhere, from negative infinity to infinity. I need to show it's decreasing. What's the derivative of e to the negative x? That's definitely negative, right? It's always negative. The numerator's negative, the denominator is always positive, so this is always less than 0. So it's decreasing on my interval 1 to infinity as well. So now, let's compute the improper integral of, it was e to the negative x. I put in a limit, right? First step is always with these improper integrals, put in a limit. Negative x. Okay. And then how do we integrate this? Another substitution. What's my substitution going to be? U equals negative x. Okay. So I can now put in my substitution. This is the limit as t goes to infinity, e to the u, and then I have negative du. And then remember, my numbers change. So what are my new numbers? 1 becomes a negative 1. And then t becomes negative t. Okay? You're taking this substitution and you're plugging in these values 1 and t in place of x. So you get negative 1 and negative t. What's the integral of e to the u? E to the u. So negative e to the u. And then I'm just going to plug in my numbers and calculate this limit. Okay? So let's plug in the numbers. It's negative e to the negative t minus a negative, so it's plus e to the negative first. That's what I need to calculate the limit of. So again, with limits, we like for things to have positive exponents because then it's easier for us to understand what's happening. So negative 1 over e to the t what's our limit going to be for negative 1 over e to the t? 0. And then I'm just left with the last thing, which is a constant, 1 over e. So my improper integral, did it converge or diverge? Converge. So what's my answer for the series? Does it converge or diverge? converges, okay? So this improper integral converged. So I can now say that my series e to the negative n converges by the integral test. Okay? Any questions on that? The integral test works very nicely when you have things that integrate, like you can actually integrate. So on that other example we did, ln of n over n, if I convert that into x's, ln of x over x, I can actually integrate that. Same thing here. After I convert into a function, I can integrate this, okay?
Will the integral test work all the time?
Only, not all the time, because part of the reason is, so if you can integrate it, then yes. But we know that integrating is a hard thing to do in general. So yeah, so for example, a place where it won't work, well, there are conditions on the integral test, right? You have to have positive terms. So if you have an alternating series, you can't use the integral test. If you have negative terms in your series, you can't use the integral test. If your terms are increasing instead of decreasing, you can't use the integral test. So there are those if conditions in the integral test, and if you don't meet those, you can't use it. So if you can use it, it'll always work if you can integrate. It's not like so think about it like this. With the divergence test, there are no conditions. You can always calculate the limit of your terms, but the problem is, so you can always use the divergence test, but it doesn't always tell you something, right? In these past examples, it's been inconclusive. So in order to have something that will always give you a result, it can't always apply to every single series. It's like a payoff balance kind of thing. I think of it like that.